Welcome to 8-7 surface area of prisms and cylinders. When we say surface area, what we're really talking about is if we were going to paint this or cover this figure, how much paint would we need to paint each surface? The technical definition is it's the sum of the areas of all the surfaces. So if we're given this figure down below, we're going to find the area of the front, the back, each side, and the top and bottom. We're just going to add all those up because sum means add. The lateral faces, if you think face, you kind of think of just a prism. So down here, you're looking at the faces. It says parallelograms that connect the bases. So if we locate the bases, the top and the bottom, okay, the lateral faces are everything in between. Likewise, the lateral surface is the curved surface of a cylinder. So it connects the bases of the cylinder. Notice, here's the base, here's another base. It's the area in between. Okay? So when we're looking at the surface of each of these, what I like to think about when it comes to a prism is let's just divide it into sections. And I think that this picture does an excellent job of it because it just kind of breaks it down. It keeps the dimensions on it. So basically, if we find the area of each surface, so we find the area of the front, we find the area of the back, we find the area of each side and the top and bottom, we add all those together because you remember it said sum, then we will get the surface area. And we're going to look at more examples of this. This is kind of just introducing it. On a cylinder, the same idea applies. Now there's a formula over here. It looks a little complicated. It's really not as bad as you might think. So if we're finding the surface area of the cylinder, basically we have to break it down like this picture does. We have to figure out what's the area of the top, what's the area of the bottom, and how can we find this area of the middle. If you take a look at the formula, this is probably the formula that you're going to use more often than not. Okay, and within the formula, there's a few things that you might notice. First off, this pi r squared. Pi r squared is the area of a circle. So basically what we're doing is we're finding the area of the top, and we're saying since there's the top and the bottom are the same, we're just going to multiply that area by 2 to get the area of this and this. Now if we look at the other one, this 2 pi r times h. Okay, 2 pi r gives us the circumference of this circle. Notice the distance all the way around the circle is the same distance as it is from here to here. Okay, so we're saying we're going to take this, find this distance, and we're going to multiply it by the height. That's going to give us the area of that lateral surface. So looking at this picture, breaking it down, the first part says 2 pi times the radius squared. The radius was 5 because we redrew it to see it. So it's 2 pi times 25. Notice we have a plus in between. And then we have 2 pi r times the height. Okay, so we're going to go with 2 pi. The radius was 5. And then the height, if we redraw it like this, or we can look at the picture and say, how tall is it? It's 6. Okay, remember, your first step, always writing the formula that you're going to use. Second step, just plugging in. We're not doing any operations yet. And your third step, we're going to compute it using your calculator. I think this one's helpful to just do it step by step. So notice a plus, so let's do everything to the left to the plus, everything to the right. We know that we're going to have to do that last because there's multiplication in here. Order of ops says we have to do multiplication before we do anything else. So we get to 50 pi plus 60 pi. If we combine, we treat pi like a variable here. We get 110 pi. And that's going to be units to the third. Okay. If you want to plug 3.14 in for pi here and solve it, that's completely fine. Okay. Or if you want to leave it like this, it kind of depends on what the question is asking you to do. Okay. If you're finding the area of each, or the surface area of each of these, go ahead and hit pause right now. Go ahead and compute each of these, showing all work, and then hit play when you're ready to continue. Your first step always should be to write what formula you're using. That way you don't make nearly as many errors. You know exactly where you're going to plug things in and how they're going to look. Okay, your second step should always be to plug in all of your numbers. Notice we're not doing any computations yet. We're just plugging them in, knowing where everything goes, and making sure that we're accurate. Okay, if you start combining your like terms, I think it's helpful to start with everything on the left. Okay, so we have 2 times 2 is 4, because that's 2 squared, and times 2 is 8 pi, plus 16 times 2 is 32 pi. Okay, again, treating pi like a variable here, we have 8 pi, we want to add 32 pi, so here we actually have 40 pi meters to the third. And depending on what it asks for, notice in this section it says to the nearest tenth. So we want to make sure that we round that correctly. We plug in pi equals 3.14, and we get 125.6 meters to the third. Make sure you remember that to the third. That tells us it is volume. I want you to try number 2 on your own. It is not an easy problem, but try to apply the same principles and see what you can come up with. And also down at the bottom, changing dimensions. Okay, it just kind of shows you if you plug in just your height and your radius, and then you double the height. So instead of using a height of 4, you're going to use a height of 8. And using this height of 8, you're going to see how the surface area is affected. And then you're going to double the radius, which is 5. So instead of 5, you're going to use 10 in this formula. And that's going to show you how, if you double the radius, how the surface area is affected. All right. Please write down at least 2 questions on this sidebar. Okay. I know that this is a little bit more of a difficult section, so it's important that you are thinking about questions and how these relate to what we're talking about. So write down 2 questions, bring these to class, we'll discuss them, and go from there. Also check out the linked videos. There's some pretty good ones on there. And if you have other questions, go ahead and just try Googling surface area of prisms and see what you can come up with on your own, because there's a lot of good resources that I may not have found.